Okay, here's the review for Unit 4, Part 1. Let's look at some of the wrong answers first. E says if the two rolls are threes, probably rolling three, the next roll is slightly less than 0.1. It doesn't change the probability of your previous rolls. It would be possible to roll the die 100 times and not get any threes. That's actually possible, not likely, but it's possible. If you roll the die 10,000 times, exactly 1,000, I don't think there's something called, sampling variation. If you roll that 10 times, one of the rolls, again, it's possible, but not even that likely. This one sounds great. If you roll the dice thousands of times, the probability proportion of times you roll three would be close to 0.1. So that's fine, or one out of, I guess it's has 10 faces, so 0.1 would be accurate there. I was trying to see what kind of dice is that. Yeah, that's what it is. Okay, a jar contains 60 marbles and 40 red marbles and 40 white marbles. The teacher draws 15 marbles randomly from the jar without replacement. The dot plot shows the number of red marbles out of 15 drawn in the 2000 trials of this process. Okay, so sometimes as much as 13 there and as little as 4 out of 15 in the simulation they had. So quite a range, usually around 9-ish. So based on the dot plot, which is following is the best estimate for drawing 3 or fewer. So 3 or fewer, well, I mean, so 3 or fewer marbles out of 15 from the jar. Fewer white ones, so white. So this is this one shows the number of red marbles. I had to read that. That's red. And we want to get 3 or fewer white. So, well, that's red. So white, I guess if there's 15, 3 would give you 12 red. So I think anything in this range fits into 3 or fewer red because it'd be 12 or more, I guess, of the red. So there'd be 3 or fewer white ones. That just takes me a second to think that through. Okay, so 1, 2, 3, 4, 5, 6, 7. If I read that right, that's 7 out of 100. Let's see. I was kind of assuming it was 100. I just went back and just, let me double check here. So 7 out of 200, which if you type that in your calculator, I believe is 0.035. So man, I just thought for sure it'd be 100. So often it's 100. So you gotta check. If you select an M&M candy at random for a bag, okay, so it's good to make the. So do not, so first let's just fill in the blanks here. So that's 0.5, 0.6, 0.7, 0.8. So this one's 0.2. That's not the answer to the question, but it is something we probably need. So I do not, what's the probability that you do not select a red candy? Oh, we didn't need the 0.2, did we? Okay, so red is 0.2. So what's the chance of not that? 1 minus 0.2, which would be 0.8. Ooh, tricky question. I thought for sure the 0.2 would help us. I guess you could add up this plus this plus this plus this plus this to get 0.8. That would be okay. Okay. So 4 students in the stat class are surveyed. 2 of the variables recorded for the 80 students were commuting status and grade level. Commuting status recorded as driving alone, carpooling, or being dropped off. Grade level was classified as either junior or senior. The following table summarizes the results. What is the probability the random selected student for the school is a senior or gets dropped off? So senior, that's this amount, gets dropped off is this amount. So out of 80, so you would think so it'd be 55 out of 80 seniors plus 15 out of 80 dropped off. Is there any overlap? I think there is, right? There's 8 folks that fit into that overlap region. So we're going to subtract that 8. So I think that would be 62 out of 80, which they nicely simplified for it. Did not simplify, so I like that better. That was just easier for us. And normally you'd simplify that. This teacher had 100 high school students. If they had a dog, cat, or both at home. Here are the results. If a single student selected at random, what is the probability the union of the two events has a dog and does not have a cat? So no cat is here, those folks, but has a dog is here. So union, the union means the word or. So either or. So you're adding up all three of those with no overlap. So the 4 is overlap, but don't count it twice. So 74 plus 4 plus 12. I think that's 0, 8, 90 out of, I'm guessing 100. So 5 should be D. A certain town, 60% of the households have fiber optic internet access. 30% have one high definition television and 20% have both. What percent of households have? So I'm just going to draw a Venn diagram. I think it's going to help us in this one. So one of them is internet access. And one of these is HD, I guess. So 20%, so 0.2. 30% have high definition, so that's 0.1. That you have to be careful. You have to subtract out the overlap. That's why I did it that way. And 60%, but you got to subtract out the 0.2, so that's 0.4. And I don't know if they're going to ask about it, but I'm going to fill out the rest. 6, 7, so 0.3 is left over. It has to add up to 100%. Neither, probably should say nor there. I'm just guessing, and so that would be 0.3 or 30%. You can draw 2 marbles at random from a jar that has 20 marbles and 30 black marbles without replacement. What's the probability that both marbles are red? So the first marble is red. These are dependent events. So 20 out of 50, but these are not independent, so I can't just multiply by 20 over 50. I'd have to do 19 over 49, whatever that is. And I think that would give us the answer of A. This looks like a Venn diagram. So A and B. So 0.6 are from A and 0.4 are from B. From there, from distributed A, 80% weigh at least 6 ounces, greater than or equal to 6, less than 6 ounces. So that would be 0.8 and 0.2. I guess greater than or equal to 6 and less than 6. 70% weigh at least, so 0.7 and 0.3, if I can read those. What's the probability a randomly chosen apple from the store weighs under 6 ounces? So here's one chance. It'd be 0.6 times 0.2. And then the other one would be this one, which would be 0.4 times 0.3, which is 0.12. And this would also be 0.12, I think. So 0.24. Yeah, that makes sense. If you add those up, you get 0.24. Here they gave us, that's nice, they gave us the diagram. Given the student who ate breakfast is selected. So we're looking at this group, which is 0.4 times 0.8, which I think is 0.32. And this group, which is 0.6 times 0.3, which I think is 0.18. Given the student breakfast is selected, so given that, so my denominator is those two added together, which is 0.5, I think. Which probably is male, I guess that would be this one, so 0.32 out of 5, which should be 64%. It says 11, but I think it's 10. Sorry about that. A stack of 4 cards contains 2 red cards and 2 black cards. I select 2 cards at random and do not replace the first card. There's no replacement. A and B are what? So definitely not independent because I'm not replacing. So independent is gone. think that one's gone. Mutually exclusive, can they happen at the same time? It's like 2 cards, one at a time. I mean, I could pick a red and a red. I mean, so red is the same. So I think they're not mutually exclusive. They can happen at the same time. Red is red, I guess. So I think it's D. Okay, so find the probability that is airline A. So you see there's a total of 160 there. So I think it'd be 160 divided by the total is 500. It's not conditional there, whatever that is. Type it in your calculator and get your decimal there, 0.32, I think. I'm guessing. Okay, find the probability that the selected flight was airline A, given that the flight was delayed. So my denominator is the delayed folks. So there's 105 delayed folks. And so out of those, 38 were flight A, so 38 over 152. Again, just type in your calculator, get the decimal there. Are the airlines A and flight A delayed independent? So there might be a couple different ways to prove this or not. So it's possible they are, I don't know. So flight airline A, so the probability of A should be the same as if the given like flight, so let's just check. Airline A would be, well, we got that's 0.32, right? And we already did the work for that. Should equal, I'm going to say it in words first, the probability of B, or delayed, given that A has happened. So given that A has happened, let's see. So the formula is probability of A should equal the probability of A given that B has happened. In other words, B shouldn't have any effect on that. Well, we just did this. Given that the flight was delayed, that's our B. And that's 38 over 105, which I think is 0.3. 0.3619. I mean, they're not far apart, but those are not equal to each other. So 0.3619. So I don't think those are independent. So because the probability of B is having effect on A, right? That's just true. So let's do this one. Say it in words first. Probability of B should equal to the probability of B given that delay has happened. Okay, so what's the probability of B? That would be 150 out of 500. And that should be equal to, let's see, delay is at 105. So that would be 37 out of 105. I don't know, let's type that in here. See what we get. So 150 divided by 500. And then 37 divided by 105. Again, so not quite, 0.3 is not equal to 0.3521, so those are not independent either. No, they didn't ask if they're independent. Sorry about that. I did all that work and they didn't, well, they're not independent. So are they mutually exclusive? So that's a good question, actually. So airline B and delayed, can they happen at the same time? Yeah, 37 times it happened that B was delayed. So these are not mutually exclusive because there's 37 folks mutually exclusive, because that means it can't happen at the same time, and 37 times it did. Boy, you got to read carefully. Random sample of 2 flights is selected. What is the probability that neither flight was delayed? This is kind of a weird question. Okay, so 2 flights were selected. So any 2 flights, I guess, that neither flight was delayed. This, so let's just find Probably that the first flight is delayed. So the first flight delayed would be 105. Let's see, wait, we want delayed or not delayed? If random flights, what is probably that neither flight was delayed? Oh, so we don't want it delayed. We want it on time. Sorry, took me a second to get that. Okay. 395 out of 500 is the first flight, right? I think these are dependent events though, because once I've had the first flight, I've already taken the flight. It was on time. How many are left? There's 394 flights left out of 499. And you're going to multiply those. Those are dependent events. You're going to multiply that to get, I think, 0.64 when you multiply those. Okay. 13, which is number 12 on your answer key here. So the probability of the randomly selected person in the United States is left-handed is about 14%. Among the 28 students in this AP Stats class, 8 are left-handed. Wow. Describe how you would use a random number generator to simulate the proportion of left-handers in the class of 28 students if there were chosen randomly from a population that is 14% left-handed. Do not perform the situation. So I'm going to assign numbers. So I'm going to say numbers 1 through 14 are lefties. And I think there's 100 here. So it's 14 out of 100, so 14%. So numbers 15 through 100. It's not by digits here as a random number table, so that's fine to say those are righties. Okay, so describe, so first I number them off. Okay, so then describe how to simulate the proportion of left-handers in a class of 28 students. So I've got to, so are repeats allowed or not? I got to think about that. So use a random number generator to get 28 numbers from 1 to 100. I think repeats are okay. So we have to mention, I don't think we're actually selecting people here. We're just saying, are you left or right-handed, and the chance of doing that. So I don't think they represent actual 100 people. It's just a percentage here, and so I think repeats are okay. So to get 28 numbers, count the number of lefties to lefties, how many lefties out of the 28 numbers you chose. Repeat many times, and record the number of left-handed folks for each trial, each simulated trial you do. The next part, looks like they did do some kind of trial here. So what does 0 represent? So that means in the simulation, they picked 28 people and 0 of them were left-handed folks. Use the results of simulation, that's probably the 8 or more. So 8 or more seems pretty unlikely. I think they did 100 this time. That's more what I expected. So 8 or more would be, so 4 out of 100, which is 4%, which is pretty unusual, right? So there's a chance of, if that's, by chance alone, there's a 4% chance of this result happening. What does this suggest about the proportion of lefties in the class? Because only 4% in the 100 simulated trials were left-handed, we think the number of left-handed students in this class are unusual. I'm not sure I would say they're lying. I just think it's an unusually large number of left-handed folks. A 2-digit number is selected by randomly choosing 2 digits from 1 to 4. Random 1, 4. The calculator uses 2 different numbers chosen. For example, if the output was 3 and 1, 3, 1 would be the number 31. Okay, and it looks like you can do, can you do repeats or not? I don't think you can, right? It says, because it says, for example, 3 followed 1 would be 31, 3 followed by 3, they would not, a new number would have to be selected. So they're not allowing repeats. So probability model, let's list out all the possibilities. 1, 2, I can't get 1, 1, but I can get 1, 3, 1, 4, I think that's all the ones. 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, and 4, 1, 4, 2, 4, 3. So there are 12 possible outcomes, and there's a 1/12 chance of each of those happening. You need two things for a probability of each outcome happening. You need to, for a probability model, you need to have the sample space listed out and what is the chance of each thing, and it's a 1/12 chance every time. Okay, find the probability the number does not start with a 1. Well, all of these do not start with a 1. So I would say 9 out of 12, which is either 3/4 or 0.75. They like to see that little bit of work, that fraction that you did there. That's good to show. What is probably the number selected to be divisible by 3? So that the number selected, so 12 is divisible by 3, 21 is divisible by 3, 32 is divisible. No, sorry, took me a second to think that through. Not divisible by 3, not divisible. Oh, I really was hoping. This is 24 is divisible by 3. Yeah, I missed that one earlier. 41, 42. If you add them up and they're multiple of 3, if you add up the digits, you'll get it. So I think it's 4 out of 12, which is 1/3. Okay, that is your review. There's the answers if you need them.